Hello, right, this one is to do with Venn diagrams. Venn diagrams, whoops. Venn diagrams. Okay, right, a Venn diagram. Let's try and get these squares, at least I can get those right, yeah. So there's a Venn diagram. And what happens is we get two circles inside the Venn diagram. They're supposed to be the same. And what we do is call that one T. T equals tea, and C equals coffee. And we're asking some people whether they like tea or coffee. Yeah, and this is how it works. Now we've got this sort of Greek letter chi or something, and that means everything. Everything. All the people we ask, all the data all together, and we'll say that that equals 20. So we ask 20 people whether they like tea or coffee, and the people that like both will go in the middle. So say we have that. And then we'll have 12 people that like tea only, 5 people that like coffee only, and 1 person on the outside who we must include doesn't like tea or coffee. Yeah, and you usually get a probability question. What's the probability that a person chosen at random, person chosen at random, who likes, what should we do? Likes tea. Yeah. So how many people like tea? Well, there are 14 people that like tea, and that's out of 20. Yeah. So 14 out of 20. You can simplify that if you want, but we won't bother. We won't bother because there's no need, because you might make a mistake. Okay, so let's do another one. Okay, so here we are. So these Venn diagrams, they change color as we go along, depending on what I'm doing. Yeah, so okay. So this is the first part of this. So let's ask some people about dogs and cats, whether they've got a pet. So, so all the people we ask is 30, and 21 have a dog, 16 have a cat, and 8 have a dog, but not the cat. Okay, so how do we fill this in? Okay, so 8 people have a dog but not a cat, so they're going to go in there. Now we've got 21 people altogether have a dog, so we know about 8 of them, so that will be 13 people that have a dog and a cat. And 16 people have a cat, we know about 13, so 3 people go there. Now, don't forget, these are only the people that have dogs and cats. So that's 16, that's 24 altogether, but we asked 30 people, so there must be 6 that don't have either. Aha! Right, let's go next one. Yeah, these are all right. Dogs and cats. Dogs and cats on Venn diagrams. Right, so let's do another Venn diagram. Here we go. All slightly different sizes. And these circles. In GCSE, we only have 2 of these to bother about. Not till you get to A levels, you have 3 of them. Then it gets complicated. Okay, so how many people we can ask all together now? So we're going to have 50 people. That's that chai thingy. So T stands for text. SM stands for what equals social media. It's an old style question. Yeah, things have moved on so quick. Yeah, so 20 use only texts. 8 use only social media, and 17 use both. And we'll have a probability question on this as well. What's the probability that someone chosen at random uses text? So let's have a look at this. So let's fill it in first. Let's change colours. Change colours. 17 use both, so stick them in the middle. 8 use only social media, so they go over there. 20 use text. Right, how does that compare to the 50? 20, 37. 37 and 8 is 45. So there must be 5 people down there that we don't know about. Somebody chosen at random, so that must be out of 50 because it's all of them use text. So 37 people use text. Good. Let's have a look at some more. Right. Got quite a few of these. Right. It's okay. There's good practice. Good practice. Let's have a look at here. Right. There, we've got a black one now. This one. Now, we're going to do this one slightly different. S and E. S equals a square number, and E equals an even number, right? And our data set, or whatever we want to call it, is we're going to use all the numbers from 1 through to 12, and we're going to put them in the diagram. And then we're going to put a probability question, a number chosen at random is even. Okay, so let's put these in where we need to go. So now we can go back to the red so we can see things. Now number 1 is neither even, but it's a square number, but it's not even, so it goes in there. Number 2 is even, but not a square. Number 3 is an odd number. It's not a square, so it goes in there. Number 4 is even, and it's a square. It's 2 squared, isn't it? Yeah. Number 5 is neither. Number 6 is even but not a square. Number 7 is an odd, but so that goes there. Number 8 is even but not a square. Number 9 is a square number but not even, so it goes over there. Number 10 is even but not a square. Number 11 is neither. And number 12 is even but not a square, so we'll put that there. Now, one thing to notice here, all these ones out there, they're all prime numbers, aren't they? Because prime numbers can't be squares, can they? 2 is a prime number, isn't it? But it's even, so it goes in there. So a number chosen at random is even. So how many even numbers have we got? 1, 2, 3, 4, 5, 6. So if we got 6 out of there were 12 altogether. So that's that. Okay, let's do another one. Good. Lots and lots of Venn diagrams. Yeah. Right, there. So, right, this one, F and G. So F is for French and G is for geography. I nearly put German there. Would have made sense, wouldn't it? Yeah. And all the people in all the world with 36 pupils, we asked them what they studied or what they liked, right? And they said to us that 20 people do French and 9 do geography, yeah? And 3 do both. I'm going to make this more because there's a theme, isn't it? So I will actually make that German. Makes sense, doesn't it, if you're asking people about languages? So that's German. And that's German. Okay, so now let's have a look. Now the probability of somebody chosen at random doesn't do French or German. Yeah. Okay, right. Let's fill it in and see what we can do. Okay, so 3 do both. Ta-da! That goes in the middle. 9 people do German, 3 we know about, so that's 6. 20 do French, 3 we know about, so that's 17. So that adds to 26, so there must be 10 people that don't do anything. Probably chosen at random is 10 out of 36. 10 out of 36. Okay, one more. No, 10 more, 100 more. There's another side to this as well. So there's a different thing that. So here, A and G. So A equals art, and G equals geography this time. This one getting muddled up with geography and German. Yeah. No wonder I didn't get a German GCSE at school. Studying, looking at maps. Right, all of the people are 295. So, do we fill these in? Let's have a look. Let's go down. So let's fill in the numbers. Yeah, so we're not giving any information this time. We're just giving all those numbers, 29 and 227. So we want the probability that chosen at random, they take art. Right, so that is going to be, how many people take art? 39. 39 out of 295. Yeah, that's fine. Now, the probability that someone, a student who takes art also takes geography. Okay? Right, so the art students are 39, so it's only going to be out of the 39. And they also take geography, so that's these 14 in the middle. So there you go, that's the probability of that. Right. So that's basically all there is to let's do one more before I get on to the second bit. The second bit is mind-bogglingly silly. Yeah, there. So we've got P and we've got S. And P stands for pigeon. And S stands for seagull. Now, we've got some bird watchers. They're going to the seaside to see what they can see. Yeah. And 28 of them, they saw a pigeon. Pigeon. Yeah. And 15 saw both. And 10 didn't see anything. Alright. They must have had their eyes shut. Yeah. So, and we're going to do a probability on this. What's the probability that a bird watcher saw a seagull? So this is somebody taken at random. Did they see a seagull? Yeah. So let's fill these in. So 15 saw both. Fill it in with different colours so we can, all lovely and colourful. Yeah. 15 saw both. 10 didn't see anything, so they can go down there. 28 saw a pigeon. So 28, 15 we know about, so there must be 13 in there. So how do we do this? The seagulls. Right, so how many people were there altogether? Forgot that bit. 50 people altogether. So we know about 13, 28. We know about 38 of them. Yeah. So 50 minus 38 is 12. So 12 people must have seen a seagull there only. So probability that a bird watcher saw a seagull is 27, all of them, out of the 50. Okay, ta-da, that's that. Now, the second part of this Venn diagram stuff is a bit weird. Yeah, it's identifying regions. So I've got to do smaller ones so that we can get them on the same page. See whether I can see how many I can get on the same bit. Okay, so there's 4 of them. So let's draw the circles in there. I think there's about 8 of these to do. Different regions. Now, this is all going to be A and B, and A and B, and A and B, and A and B. Now, what we're going to do is identify a region given some information. So first of all, we're going to identify the region represented by A. So all we need to do now is this. Everything that's A. Yeah? And then identify the region that is B. There. That's the region A, and that's the region B. Now, this one, we have a little, like a apostrophe or something on there, and that means not. So this means not A. So everything that is not in A is all this around there. And what you, oh, I went a bit wrong there. What happens here that you usually get in exam questions, lots of different shapes, lots of different pictures, and you have to match up the letters with what you're seeing. Or, so here we go, everything is not in B. So not B is all of this. So this is all fairly straightforward. Yeah. And in a minute we'll use combinations. Yeah. So not A and not B. Yeah. Okay. So let's come down here and do a bit more. So we need to do some more of these. I suppose I could copy and paste and all that kind of thing, but that's way beyond me. We were mathematicians, not computer scientists. Not computer scientists. Let's have that one there. And this is all drawn out for you anyway, so it doesn't really matter. So there's another 4, yeah? So what we're going to do here is, again, do this. And you can watch this at double speed if you don't like watching me draw these. Oh, look at that. Getting better. A, B, A, B. Okay, A, B, A, B. Right, fancy graphics doesn't get you anywhere, yeah. Okay, now what we're going to do here, we're going to introduce a new symbol. This one, A, B. And what this means, this symbol is intersection. Yeah, and when we're doing intersections, we use this pattern. Yeah. Now, okay, so what we're going to do is, if we take it one at a time, we do everything that is in A. Yeah, that way. And then we flip and we do everything that is in B. And where we get this crosshair pattern, that is the area that we're after. So it's this little bit here. Yeah. And there is another. It's this. And this is called the union. Yeah. And for this, we just use it one way. Intersection, both, union, one way. So we need everything that's in A and everything that's in B. And so this now means that it's the union. They have joined forces. Yeah. So it's all of this and all of this. Okay, the union. There. So it's different. Yeah, it's different. So what are we going to do down here? We're going to do, let's have a look, see what we've got. We're going to do a combination of those knots. So we've got knot A intersection B in that one, and knot A union B. Okay, so remember intersection, and we do the crosshairs. And that one we just do the straight ones. Okay, so everything that's not in A is all this stuff around the outside. All the way through the B, we do that's not in A. So everything apart from the actual circle A itself. Okay, now everything that is in B. So we now do it the other way around. There. Okay, and where we get the crosshairs, that's the region that is defined by the not A and B. We get this sort of crescent moon type shape. Yeah. There. Lovely. Yeah? Let's do the other one. Now, everything that is not in A is this. Oh yeah, we go through there. So intersection and union, that's the thing to remember. One's crossed, and everything that is in B, straight lines, is in B. So we just need to fill that a little bit in there. Yeah. So this one is now all of this around the outside. Yeah. I should use a bigger brush, shouldn't I? But it includes that bit there. 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 Right, okay. So they are. So it's completely different. It's not even opposite. Not even the inverse of it, because there's a bit in the middle that's used. Right, so we've got two more to do. You're like this. Two more. Let's come back to a different colour and do the shape and do it. Right, last two. One and one. There. Right. So here's our Venn diagram. And of course, these are A and B, aren't they? A and B. And this one, we're going to do A intersection B and that. Now that is the same as that. It's the same thing, yeah? But just put a bracket around it, it means that everything inside the brackets is not. So again, this is an intersection and you're going to use the crosshairs. So let's do a change of colour. So everything that's not in A, everything that's not in A. Okay, everything that's not in A. Now everything that's not in B, and we do it the other way around, everything that's not in B. Okay, so what does that do? Everything that's not in A, not in B, it's all this stuff around the outside, isn't it? So all the places where we've got the crosshairs, crisscrosses, that's there, that one. There, okay, there, that one. So now the very last one is do a union in a bracket with a knot. So this is not in A, so this is a union, and we just use singles. Everything is not in A. Okay, and everything that is not in B. Right, same way round. Everything that's not in B. It's all of that lot, isn't it? And this bit as well. That's not in B. So this is everything, basically. Yeah. So it's that. Oh, it's and it's that. Yeah, and it's that. And it's that. So it's everything apart from that little bit in the middle, yeah? Everything apart from the little bit in the middle. So that is the area of there. So there you go. So that is the lesson on Venn diagrams.